This is an additional portion of the lens lab that I wanted to discuss with you. Uh, there's a couple other videos that are older, and this one takes into account the fact that if you're doing the lab at home, you and you're doing it in the semester where I haven't taught the circuits portion of the lab yet, you don't have a way to create a light source. So I'm going to show you how you can create a light source that you can use for the lens lab if you don't have your circuit kit. So here's what I'm going to do. First of all, I'm creating an object. An object is basically a drawing on a piece of plastic. I'm an object for that matter, but you'd have to shine light on me for me to reflect it well enough to be seen as an object. So it's a lot easier to create an object by creating a light source, putting it in a dark room, and shining the light source through something. In this case, I have a carrot. I have a picture of a carrot, which I cut out of a plastic bag. There was a plastic bag that had a carrot on it. I thought, oh, I'll use the carrot as my image. So I have this, hopefully you can see it there, this picture of a carrot here that I cut out and attached it to a piece of a tubing that could be bathroom tissue or something like that. And I just made sure that it was attached with some tape, or in this case, a little twist tie onto here. So I'm going to be shining a light through this, and I have a light that'll fit in here. You can see I'll shine it there, and you're not going to be able to see much probably other than maybe the carrot stands out more. But what I'm going to do is I'm going to shine this light, you can see I can change its direction, through a lens, and that's what I'm going to be doing in this part of the lab. Kind of like shining a flashlight, but I want an image that the flashlight can see. So the image is going to be located right here, and I'm going to set it up for you, which you'll see in the next part of the video. Okay, I am going to show you the results of this activity. So what I have here is the light source, which is on. You can see that the light is shining. And I have the lens right here. And I set the lens in a jar, or in a plastic jar, and I filled it. In this case, I have some nuts and bolts. You could use dirt, you could use soil, but something that'll keep it upright and in the light, and so that the light will from the source will shine through the lens. And then in the distance, hopefully you can see that there's an image. You can see the carrot, and I'm going to rotate it a little bit. Let's see if you can see this. I'm going to, I think you can see it maybe like that. I'm going to rotate the carrot ever so slightly. You see the carrot turning. If I move the lens a little bit, it gets blurry one way or the other. There's a sweet spot, the Goldilocks spot, where you see the carrot with a lot of clarity, and that's when the image distance, that's when you actually have an image, and the lens equation should work right there. So if I measure the separation between the image here and the lens, and the separation between the lens and the light source, I have my image distance and my object distance. Now if I measure the size of this image using a ruler, compare it to the size of the object, I have my object size, which is not changing, and the image size, which will change as I move things around. All right, so that's what I'm going to be doing for the next few portions of video. I'll be making some measurements. So I'm going to start off with the image distance. In this case, the image distance is the distance from the lens to the light source in this case, and you could do this as well. You'd need a ruler. I have 39 centimeter distance between the light source and the lens. Okay, and so that's my image distance. My object distance is quite a bit more than that, over a meter. So my meter stick is not long enough to do it, but I'm going to use it twice. I'm going to mark it here with my finger. You can't see what I'm doing, but I'm measuring the distance between the image and the lens, and it looks like it's 1.58 meters. So I have the image distance is 1.58. The object distance, I think I said, was 39. I'm going to record that. Verify my object distance. Yep, 39 centimeters, or 0.39 meters. I'm going to measure the size of my image. And let's see if I can have you watch me do that. The size of my image here. Take my ruler, do something like this. And try not to block it, but it looks like it's about 10 centimeters tall. Size of my image is 10 centimeters. Size of my object is not going to change, but I'll make that measurement right now. My object is about 3 centimeters tall. There's a little bit of error here in my measurements, probably about a 3 millimeter error. Let's see if you can see me. Yeah. Okay, so there's my object again. And now what I'm going to do is I'm going to change something. I'm going to move my object to a different location, and I'm going to have to readjust everything so I can then see an image again. So let's see. Well, I'll move my object a bit. Now, I think I'll move everything a little bit closer. I'm going to move my object a little bit closer here. Now my image is blurry. I don't see it anymore. So I have to adjust the position of my screen down there because I moved my object a little bit closer to the lens. It's now not 39 centimeters away. It's closer than that. So I'm going to have to do something in my image all the way down there so that I can get my, so I can adjust its position so I can actually see an image again. So I'm going to move the computer so you can see this. But if you have your own lens, you can play with this. It's worth it. It's worth being able to see what changing these does if you have that experience. Very worthwhile. All right, let's see. I make that closer. Can actually be too close. I'm going to try to move it a little bit again. Move everything around a little bit again. Sorry about that, but that was too close. So now my lens, you can see I've got an image there. My lens is now 50 centimeters away from my object. Here's the image. I'm going to adjust the image position so I can really see it. There we go. It's pretty good there. You can see my carrot. It's always going to be upside down of what it is over here. Here my carrot is right side up. Right here my carrot is upside down. So it's a normal thing that happens is things get flipped. So my object distance, I already said, was about 50 centimeters. My image distance here is about 82.5 centimeters. My image size, it's a little hard to see the upside, this part of the carrot, it's in the shadow, but I'm going to estimate it as best I can. So my image size is about 4.5 centimeters. The object size hasn't changed. I'm going to do this one more time. I'm going to come up with another position of my lens relative to my object. I'm going to push the lens further this way. And I'm going to come up with another image location. Let's see if I can find it. It's going to be my carrot. There it is. There's the carrot. I see it now. Smaller now, isn't it? You can see that right there. It's a lot smaller. So things have shifted. So now let me see what my distance of my object to my lens is. It looks like it is about 72 centimeters. My image distance, about 54 centimeters. My image size, it's a lot smaller now. Look at that. Image size looks like it's about 2 centimeters. It's a little hard to measure that image size exactly. Approximately 2 centimeters. Take into account that there's some error there. Okay, so I'm just going to do those 3 measurements. If you're on your own, you have a lens and a light source and something you can rig up for a screen. You have to make sure they're all in line. Try doing this. You can make as many as you want, but I'm just going to do 3 right now. And with these 3 measurements, you can compute the focal length. There's an equation for you that you can use. The focal length should be the same for the lens. The lens isn't changing for all 3 cases. So it should satisfy the equation all 3 times. So try seeing if you can calculate the focal length for those 3 cases. And also see if it's consistent with the magnification of the lens. All right, there's one other part I'll show you in the next segment of this video. Since it's a little bit hard to see, I thought I would include a quick picture of the object here. And again, I measured that during the lab. That caret right here in the middle of that piece of plastic is the object that's being used. It's upright, notice. And in a moment, I'm going to show you a picture of the image because I realize they're a little bit probably hard to see, if not impossible to see in the video. So you'll see the image in a second, at least a photo of it. And here it comes. There's the image of the caret. Notice now it is upside down. And I do have a ruler next to it that you can make the measurement of, although this isn't necessarily one of the cases exactly as we did. But I just wanted to show you what the image looks like that I was measuring, because you may not be able to see it in the actual video that I'm showing unless you magnify the video significantly. So it's one of the challenges of doing optics lab and trying to video it. It's a dark room, it's hard to see everything, and it needs to be dark for me to be able to see the image. So if you can do it on your own, all the best. There's another section to this lab in just a moment, but I put this interlude in here so you can see what it is I am looking at. Okay, here's the rest of the lab. All right, the last portion of this lab, I'm not going to change the position of my object, nor am I going to change the position of my image. The only thing that I'm going to adjust here is the position of my lens. So my object distance and image distance are going to change, but their sum is going to stay the same, because their sum is this distance plus that distance. That sum won't change. So we're going to see where we see an image there. Now, I already did one of these. The last one I did had an object distance of 72 centimeters and an image distance of 54 centimeters. I'm going to see if I can see another object here by adjusting this lens position here. And I actually saw this demonstration at the Exploratorium many years ago, and I thought, wow, this is perfect for physics class, because it's relatively easy to do. But they had a similar setup at the Exploratorium, so I used that here. All right, so here goes. I'm going to try to focus this in so you can actually try to see if you see the image here. You can see there's the image right there. It's maybe a little hard for you to see that unless you magnify it. There's an image of the caret right there. I'm going to now bring my lens closer. That image is going to get blurry. Let's see. And then hopefully I'll see another one soon. Let's see. Okay, there's another one there. That's a different one. The lens is now at a different location than it was, but I see the caret again. So there's another point between the image and the object where I can place the lens and I can see that caret. And I'm going to see if I can measure that distance. So I have the distance from the image to the lens. Looks like it's about, let's see here, get it as sharp as I can get it. Looks like it's about 72 centimeters. That's the image distance now. The object distance here, what do you think it's going to be? You could predict what it's going to be. What would you say? And I see that it's about 54 centimeters. Interesting. So I have di is equal to 72 centimeters. Do is equal to about 54 centimeters. Now I'm going to measure the image size here as best I can. It's a little bit bigger than the other one was. It's actually a little bit bigger than the actual object size is. Images can be bigger than that. I see, it looks like it's about 3.5 centimeters. And that is all the measurements for this lab. As I said, if you can do it on your own, there's a lot to be said for that if you're able to pull it off. If not, you have the data that I just collected. Okay,